Hi, my name is Eric Tuffius, and I am an engineer at ON Semiconductor. Today, we are going to discuss a battery fuel gauge IC solution that provides a highly accurate, efficient measurement that extends the battery life for a variety of portable equipment. Today, battery-powered products have become a major part of our everyday life. We see battery-powered products pop up in everything from cars and trucks to small medical solutions. Here at ON Semiconductor, we are creating market-leading solutions geared towards extending the life of your battery. Many of us have experienced dropped phone calls or a lost document on a laptop due to a dead battery. Because of situations like these, the consumer monitors the battery indicator and gets extremely anxious when the battery level drops below 20%. For example, if the accuracy of the battery monitor is 8%, then when the battery level reading reaches 10%, there may really be only 2% of actual battery life remaining. The device needs to begin closing down non-critical functions with a 10% battery reading compared to a 2% battery reading with a perfect measurement. The better the device can detect the remaining charge on the battery, the longer everything can be left operating normally. This accuracy needs to be maintained over the lifetime of the device. Today, most fuel gauge ICs use the Coulomb counting method, which uses an expensive precision current sense resistor to continuously monitor the power being drawn from the battery. This approach requires the monitoring circuit to operate continuously when the product is being used. The circuit integrates the current over time, along with the knowledge of the maximum battery power to calculate the net power available. The disadvantage of the Coulomb counting method is that there is no account for battery self-discharge events, which happen in parallel to the load in the sense resistor. These self-discharge events raise the ambient temperature, creating a shift in the value of the precision current sense resistor, thus also contributing to an inaccurate power measurement. Secondly, this high-cost precision current sense resistor wastes precious power that cannot be used by the device. And finally, the battery has to be fully charged every time for an accurate calibration. To overcome these challenges and provide battery-powered device users the best possible experience, ON Semiconductor has introduced the LC709203F battery fuel gauge IC. The LC709203F measures the remaining power of a single-cell lithium-ion battery. This industry-leading fuel gauge IC enables the device to display accurate battery levels using our proprietary monitoring method and achieves the lowest power consumption in the industry. The LC709203F reduces consumption in both active and sleep modes over 87% and up to 60% respectively, with an error under 2.8%. Our IC can accommodate any emerging lithium-ion battery chemistry type to reduce future learning curves. ON Semiconductor's proprietary battery monitoring method does not use a current sense resistor, but uses a high-precision analog-to-digital converter to measure the battery voltage. The system memory is then loaded with the characteristics of the battery being used. The advantage of this method is that battery life can be increased by only taking periodic readings when the battery has a lot of charge. As the battery power drops lower, more frequent readings are taken. Also, with our proprietary method, the battery does not need a full charge for calibration. Even a half charge, our method is able to calibrate exactly how much power is remaining. By effectively monitoring the voltage, any battery self-discharge is accounted for. No temperature changes, no thermal sensing drifts, just accurate. The LC709203F measures the battery voltage and the temperature at precise time intervals, and uses this in conjunction with the loaded battery characteristics reference table to precisely determine the amount of power remaining in the battery. We have conducted a benchmark test showing our superior fuel gauge accuracy by using a smartphone under a 0 Celsius temperature environment. As everyone knows, temperature affects battery performance. As the ambient temperature drops below 0 Celsius, the series resistance inside the battery causes the battery voltage to drop. The LC709203F not only measures the voltage, but also the temperature to compensate its calculation appropriately. We hooked up our evaluation board to the smartphone with the competitor's IC installed to measure both ICs under the same conditions. We purchased a new battery and set it to airplane mode to remove any potential bias. The smartphone's backlight was on and the video was playing during the measurement. Here are the test results. As you can see, the competitor's errors reached up to 6% when the battery remaining level was decreased, then dropped immediately from 6% to 0% to shut down, whereas our IC measurement errors were lower than 2.8% throughout the test. The comparison table shows that the LC709203F has 4 times less external components than competitive solutions. The LC709203 supports design engineers with no external current sense resistor. Our IC enables not only a reduced bill of materials cost and reduced design time, but also increases reliability as there are fewer components to potentially fail. Moreover, it reduces printed circuit board size by approximately 77.5%, making the package size about 45% smaller than competitive solutions. Due to its fewer external components, the IC reduces total power consumption. The IC's operating current is approximately 1/10 of the competitors at 15 microamps compared to 118 microamps. As you can see in the table, we can reduce over 87% of the power consumption in active mode and up to 60% in sleep mode. The LC709203F is used for a variety of products such as wireless handsets, smartphones, wearable devices, MP3 players, and digital cameras. For more information regarding this product and the complete portfolio of ON Semiconductor battery fuel gauge ICs, please contact your local ON Semiconductor sales representative or authorized distributor. For more information regarding fuel gauge ICs, please visit us at www.onsemi.com. Thank you.